Hi guys, hope you're having a wonderful day. Today we're going to practice single replacement reactions. So how do you know that you have a single replacement reaction? Well, you're going to have a compound and an element. Now, if you remember, we did combustion reactions, and in combustion reactions we also had a compound and an element. But in a combustion reaction, the compound has to be a hydrocarbon and the element has to be O2. So if you have a compound and an element, check if you have a hydrocarbon and O2. If yes, then that's combustion. If no, if it's any other element or any other compound, then that means it's a single replacement. So with single replacement, what you do is you first look at the element that you're given. So we have CuCl2 plus K. So this is our element here. So the first thing is you look at the element and you ask yourself, is this a metal or a non-metal? And so in this case, potassium is a metal. So then you compare it with the metal that's in your compound. So we're going to compare potassium with copper. And what you want to do is you want to use your activity series. So in the lab that we did a little activity series with, I think there was copper, magnesium, zinc, and iron. And we looked at which one is more reactive. So we came up with our own little activity series. An activity series is a list of metals based on their reactivities, in order of their reactivities. And so if you look at the back of your periodic table, you will find this activity series. It looks a little bit different, but it's the same list of metals. And so lithium being the most reactive in terms of single replacement reactions, and gold here is the least reactive. So if you think about it, if you have a very reactive element, it's going to react and form a compound. It's going to react with something else so that it combines and forms a compound. If you have a pretty stable, not reactive element, it's happy the way it is because it's pretty stable, so it's not going to want to combine with other elements. And so the most reactive element is going to be the one that's most likely to be in a compound. So the most reactive is going to be in a compound. The most reactive, or the more reactive, will be in a compound. An analogy to that is reactive or active, like social. If somebody's really social, they're going to be with somebody else. If it's somebody that's not very social, not very active, they're going to be happy the way that they are by themselves. So the more reactive element is going to be in a compound. So back to our potassium and copper, what you want to do is compare the metal with the metal. So if your element is a metal, you compare it with the metal. If your element is a non-metal, you compare it with the non-metal. So you compare two things that are similar to each other, two metals or two non-metals. So potassium and copper, you look for them right here. And so potassium is right here, pretty reactive. Let's see if we can find copper on this list. Copper is down here. So the more reactive element will be in a compound. So you ask yourself, which one's more reactive? Potassium is more reactive based on the activity series that we see here. So potassium is more reactive. Is it in a compound? No, it's not. Well, then it's going to react to be in a compound because the more reactive one will be in a compound. So what's going to happen is the potassium is going to go and kick out the copper. So the copper is going to get kicked out and now it's by itself. And that's okay because copper is not very reactive compared to potassium, so it's okay being by itself. And the potassium is going to take copper's place. So the potassium came in, kicked the copper out. Copper's by itself now, and the potassium takes the copper's place. So we're going to form a compound between potassium and chlorine. And as always, whenever we form compounds, we need to make sure that they are neutral. So K plus and Cl minus. So we're going to form KCl. And then we balance it. So we'd need two of these and then two potassiums. Let's try the next one. CrF3 plus Ag. So you look at the element that's by itself and you ask yourself, is it a metal or a non-metal? In this case, it's a metal. So then you compare it with the other metal that's in the compound, which is the chromium. So let's look at chromium and silver. So chromium is right here, right there. Silver is down here. Which one's more reactive? Chromium is more reactive. Is chromium in a compound? Yes. The more reactive will be in a compound. Chromium is already the more reactive. It's already in a compound. So that means no reaction will occur. Why? Because the more reactive one is already in a compound. So some of these single replacement reactions, the answer will be no reaction. Okay, next one, Hi plus Ca. So calcium is the element by itself. It's a metal. We're going to compare it to the metal that's in a compound. Well, you look at this compound and there is no metal. So Hi is an acid, and acids are a little bit unique. They're a little bit different. In acids, hydrogen behaves like a metal. Even though it's a non-metal, but it behaves like a metal. How? Because it is positively charged, and so the hydrogen here behaves like a metal. And if you notice on here, you will see that hydrogen is listed among the metals. Even though it's not a metal, but sometimes it behaves like a metal when it's in an acid. So there's hydrogen. Let's find calcium. Calcium is right here. You say, which one's more reactive? Calcium is more reactive. Is it in a compound? No. So that means a reaction will occur. So calcium will come in. It will kick the hydrogen out. So now hydrogen's all by itself. Remember, hydrogen is diatomic, so it's H2. And then we're going to form a compound between calcium and iodine. So calcium is 2 plus, iodide is I minus. So CaI2. To balance it, we need 2 of these. Okay, you try this one, pause the video, and then when you're ready, play it again and see if you got the answer right. So you're going to look at the element by itself. It's lithium, it's a metal. So you compare it with the aluminum. You check aluminum and lithium. Lithium is up here. Aluminum is here. So which one's more reactive? Lithium is. Is it in a compound? No, that means a reaction will occur. So lithium will kick the aluminum out. So now aluminum is all by itself. And then lithium will form a compound with the oxygen. Li plus O2 minus, so Li2O. And then we'll need to balance that. So we're going to need 3 of these, 2 of these, and 6 of these. Let's try this one. Again, pause the video and then play it when you're ready. So mercury is a metal. You're going to compare it with the metal. Now we don't have a metal, but hydrogen behaves like a metal. So here is hydrogen. And here is mercury. Which one's more reactive? Hydrogen is. Is it already in a compound? Yes, it is. So no reaction. Remember, the more reactive one is going to form the compound. So if it's already in a compound, no reaction. Oops. Okay, let's try this one. KBr plus Cl2. So Cl2 is the element that's by itself. We're going to compare it to something similar in the compound. So Cl2 is a non-metal. So we compare it with the non-metal. So if it's a metal, compare it with the metal. Non-metal, compare it with the non-metal. So which one's the non-metal? The bromine. Now you'll see there is no chlorine or bromine here. Why? Because this is a list of metals, right? So when it comes to non-metals, I'm only going to ask you about the halogens, and I expect you to remember the trend on the periodic table for reactivity of the halogens. So remember, fluorine is the most reactive, followed by chlorine, followed by bromine, followed by iodine. So this one's the most reactive out of these. So based on that, between chlorine and bromine, chlorine is more reactive. Is chlorine already in a compound? No, so a reaction will occur. So now the chlorine will come in and kick out the bromine. So bromine is now by itself. Bromine is diatomic, so Br2. And then we're going to form a compound between the potassium and the chlorine, so KCl. And then to balance it, we need 2 of these and 2 of these. Okay, let's try this one. Pause the video and then see if you get the right answer. So the element by itself is iodine. It's a nonmetal, so you compare it with the other nonmetal. And so chlorine is more reactive than iodine, based on the trend on the periodic table. Chlorine is more reactive. It's already in a compound, so no reaction here. Let's try the next one. Ali3 plus Br2. So bromine is the element by itself. It's a nonmetal, so we are going to compare it with the iodine, which is also a nonmetal. Between those two, bromine is more reactive. Is it already in a compound? No. So you're going to have a reaction. So try to do your reaction. So bromine will kick out the iodine. Then you're going to form a compound between aluminum and bromide. So AlBr3. And then to balance it, you need 2 here, 3 there, 2 here, and 3 there. Okay, let's try this one. Pause the video and then play it when you're ready. So zinc is the element by itself. It's a metal, so we're going to compare it with the other metal, which is iron. And you find it on the activity series here. So let's see if we can find zinc and iron. Iron is right here. Zinc is right there. So it looks like zinc is more reactive. Is it already in a compound? Nope. So that means a reaction will occur. So the zinc will come in, kick out the iron. So the iron is now by itself. And then we're going to form a compound between zinc and sulfate. So ZnSO4. And then to balance it, we need 3 of these, 2 of these, and 3 of the zincs. Okay, so as always, try your worksheet. Let me know if you have any questions. Bye, guys.